Well, hi there, boys and girls. Today we're going to take a look at points of intersection on polygraphs. And let's just get started with this. We're going to take a look at two graphs. I'm going to do r equals 1 minus cosine theta. And then I'm going to look at r equals cosine theta. And we're going to take a look at when these graphs intersect each other, and it's really good if you can graph these by hand so that you get sort of an idea of what your answer should be. First thing I'm going to graph is the r equals cosine theta. You should know that's a circle. That's a circle here with a diameter of 1, and it's going to just go like this. I'm going to do my best of graphing this. Of course, we could pick some points. If we plug in, say, 60 degrees, the cosine of 60 degrees is 1/2, so it should be about right here. And of course, it's symmetric, so put it about right there. And you just draw a little circle like this. So there's a picture of r equals cosine theta. r equals 1 minus cosine theta, we know makes a cardioid. And since it's a 1 minus cosine theta, it's a cardioid to the left. And this actually ends up going all the way out here to -2. Whenever theta is 180 degrees, the cosine of 180 is -1, and 1 minus -1 gets you all the way out there to +2. And then when theta is 90 degrees, cosine of 90 is 0. 1 minus 0 is just 1, so it's up here and then down here. And we know the graph then cuts in like this, makes a little cardioid. So I'm going to do my best to smoothly draw that. I sort of had a little hiccup there. See if I can maybe correct that a little bit. So that's okay. And I can tell that I should have 2 points of intersection. On top of that, I got a pretty good estimate of what they should be. It looks like it's about 60 degrees and 300 degrees. But we have to do the algebra and the trig to prove this. So we want to know points of intersection. And whenever things intersect each other graphically, their y equations, or in this case the r equations, you set them equal to each other. So we're going to set 1 minus cosine theta equal to cosine theta. And we're just going to do some algebra first. I guess I can add cosine theta to both sides, and I'll get 1 equals 2 cosine theta. And then divide by 2. And then I've got cosine theta equals 1/2. Now here I've got to switch gears and get out of algebra mode and go to trigonometry mode. When is cosine equal to 1/2? Well, you should know this happens when theta equals pi over 3, which is 60 degrees, and when theta equals negative pi over 3, which is negative 60 degrees. And a negative angle just means we're going clockwise instead. Negative 60 degrees is coterminal with 300 degrees. And I have my solutions. I found 2 of them. And now I'm going to actually label the points. I'm going to label what this point is. We're going to put them in r comma theta. So what is the r? I guess I can plug 60 degrees in here, and I get that cosine of 60 degrees is 1/2. So my r is 1/2. So that's 1/2 comma 60 degrees. There's r comma theta. And then if you plug in 300 degrees, you also get 1/2. So the other intersection is 1/2 comma 300 degrees. So there are my 2 points of intersection for this graph. Let's take a look at one we might have to do a little more inspection. Let's graph r equals sine of 2 theta, and I want to make this I'm going to make it 2 sine of 2 theta. So let me erase that real quick and edit that. I want r equal 2 sine 2 theta, and I also want to look at the graph of just r equals 1. Okay, so r equals 2 sine 2 theta. We should know that this is a rose, and this number in front of the theta is even. That means that we have double that number, or 4 petals. And on top of that, we know how far apart they're spaced. We know that we do 360 divided by 4, which is 90 degrees. We know that they're 90 degrees apart. And sine reaches a maximum value at 90 degrees. The way you make 2 theta equal 90 is you plug in 45 for theta, because 2 times 45 is 90. The sine of 90 is 1, times 2 is 2. So out here at 45 degrees, I have a maximum here. And I know my first petal looks something like this. and then the next one would be at 135, and then at 225, and then over here at 315. So let's see if I can draw a few more without making it really silly. You know, I didn't like that one very much. That one was a little better. This is harder to draw than you think. Alright, so there we go. Now I'm going to graph r equals 1. r equals 1 is simply a circle. It's a circle centered at the pole, and it goes out a radius of 1. So it's this circle right there. Alright, so let's take a look at our intersection points. I have 1, 2, 3, 4, 5, 6, 7, 8 points of intersection. I can't really approximate them. I don't know how well I did with graphing them. Looks like maybe 30, but I don't know. I'm a little off. Did I draw that correctly? Over here, it's definitely not at 150, and so I don't know if these numbers are nice or not. So let's see if we can trust some algebra and trig. So I'm going to go back to how to solve this. You set 2 sine of 2 theta equal to 1. You set them equal to each other to find points of intersection. I'll divide by 2, which will tell me that sine of 2 theta is equal to 1/2. And then I have to think, what angle is sine equal to 1/2? And that would be, well, at pi over 6 and also at 5 pi over 6. So I'm going to set 2 theta equal to both of those. And I guess if you want to, we can stay in degrees because we are in degrees on my graph here. So that's 30 degrees and 150 degrees. Now we're going to divide by 2 and we get theta equals 15 degrees and theta equals 75 degrees. And so I have 2 points of intersection. They are at 1, r, comma, theta, and also 1, comma, 75. So that's, I didn't do a very good job with this first petal. It should have been more like this and then up to that, because that first point is at 15 degrees and then the next point is at 75 degrees. So I didn't do a very good job drawing that first one. Now that is only 2 points of intersection, and I know that I have 8. So what I can do is use general solutions and come back to and add, 30 degrees plus 360 in and 150 plus 360 in, and take a look at the general solution. So I really should have said that 2 theta equals 30 plus 360 in, and 2 theta equals 150 plus 360 in, and then divide by 2 and I get theta equals 15 plus 180 in. Notice I divided everything by 2 there. And theta equals 75 plus 180 in. So it looks like I can add 180 to these thetas to get some more points of intersection. So let's add 180 to both of them. I will also get, if you add 180 to 15 degrees, you get 195. And then if you add 180 to 75, you get 255. Now let's go take a look at those points. 195 would be a little past 180. That'd be this point right here. 255 is this point right here. I now have 4 of them. Well, let's see if I just add 180 to, again, what happens. If I add 180 to 195, I get to 375. 375 is coterminal with 15 degrees, and I get back to this point. And if I keep adding 180, I'm only going to get these 4 points of intersection. 1, 2, 3, 4. But I know that I have 8. And you can do add 360, subtract 360, or add 180 and subtract 180, sorry. And you're never going to get these other 4 with these 2 equations. That's because r equals 1 is not the only equation for this circle centered at the pole with a radius of 1. That is also equivalent to r equals -1. Remember, it's okay to have a negative radius. For example, the point 0 degrees -1 is actually right here. And the point 90 degrees -1 is down here. And so I need to set 2 sine 2 theta equal to -1 as well. And if I didn't know what these graphs looked like, I wouldn't see that there was 8 points of intersection, and I guess I would have only got half credit on this question because I only got 4 of them. So let's go get the rest of the points of intersection. I'm going to set 2 sine 2 theta equal to negative 1, the other name for that circle, divide by 2, sine of 2 theta equals negative 1/2, and then where is sine equal to negative 1/2? Well, sine is negative 1/2 at 7 pi over 6, which is 210 degrees. Sine equals negative 1/2 there. And also at 11 pi over 6, which is 330 degrees. So I have to set 2 theta equal to 210 degrees. And I'm going to go ahead and do the general solution, plus 360n. And also 2 theta has to equal 330 degrees, plus 360n. I'm going to divide everything by 2, and I'll get that theta equals 105 degrees plus 180n. And theta equals, what is that, 165 degrees plus 180n? Make sure that's right, 160, yeah, that's 330, okay. So my next points of intersection would be 1, 105 degrees and 1, 165 degrees. Let's go back up there and see if that gets me other 2 points that make sense. 105 degrees and 165. Well, 105 degrees would be this one right here, and 165 would be this one right here. And if I add 180, I'll go get these other 2 to get my 8 points of intersection. So let's go down here and go ahead and write those down. So if I add 180, I'm going to get 1, 285, and then 1, 345. And those are my 8 points of intersection. So you have to be able to graph these without a graphing calculator to get an idea of where they are, how many you have, and whether or not you have to do something like call a circle with radius of 1, r equals 1, or r equals negative 1. All right, well, that's it, and I'll see you guys tomorrow.